Hello. I've had a few questions from students in email and consultations about auto layout constraints, and specifically after the week 7 lab class where we had this example you can see on screen now, where we did something a little bit different with well, a little bit more complex than we'd done before, and we had text fields that took up half of the screen here. So I wanted to spend a little bit of time talking about constraints in general and how you should set them up. First thing to realize is that typically we're displaying our views on a device with a fixed area. Okay, so that might be within a window on an iPad, or it might be the entire screen on an iPhone. So with the different iPhones, they have different widths, screen widths, but they're fixed size. And obviously if you turn them sideways, that is tilt them and change the orientation to landscape, then they have a different width and height of the display. The fixed width means we have some known information. And the known information here is basically that from here over to here. And I don't know exactly what this size is in terms of pixels, but let's call it 400 pixels for the sake of argument. Okay, so what we're typically doing when we lay out a text field or a label is we're setting constraints on it, and those constraints need to provide enough information that they can inform both the position and the size of that element. In the case of a label or a text field, you can assume that their height is fixed, and it's based on the size of the font that is displayed within them. Their width is not fixed. So what do we usually have to provide? We have to provide information to allow that to be calculated. So if you imagine that the size of the screen is 400 pixels across, then for this title text field, we need to provide a constraint here that says, say, 10 pixels, a constraint on the right that is 10 pixels. And once we have this, if I said this text field is called element A, and I asked you for its width, you could compute that width for me, right? Because it's just the overall width of the view, 400 pixels, minus 10 plus 10, the padding on both sides. So we know this is going to be equal to 380. In terms of its x position, we know that the view, the left-hand side of the view here is 0, so this position, the x position of the view, must be 10. We can work out its y position in the same way from the top. This is why things have to have constraints to the left and the top and the right-hand side. And it's okay if these things are a chain of constraints. So for example, what we might know here is we might know the height of this label is a fixed size based on the text within it. We might know a constraint to the top, which might be, say, 10 pixels. The height of it might be 20 pixels. A padding from here to here might be 10 pixels. So now we know the y position of this view is 40. And we know its height because it's got a fixed height. So what we want to be able to do is have enough constraints that they give us all the information we need for these views. Okay, let's have a look at the cases of the latitude and longitude one. Basically what we had here is a constraint here that said 10 pixels, a constraint in the middle that said 10 pixels, and a constraint on the right that said 10 pixels. Now if we call these views B and C, and I wanted to find the width of these things, I can't actually do it. There isn't enough information there. I know the overall view width, 400. I know that together the width of B and C must be 400 minus the 3 constraints, which are each equal to 10, so that's 30. So what I do know is I know B dot width plus C dot width is equal to 370. 410 minus 30. But there isn't enough information there. So the solver that sits behind auto layout can solve this in a number of ways, and it's ambiguous. There isn't enough information to give you an exact value. So it might make B twice as wide as C, for example, or it might make C twice as wide as B. So that's where the added constraint that we put in this example, we said we need an additional constraint, and that additional constraint says B.width is equal to C.width. As soon as you know that each of them must be half of this 370 value, right? Which is basically 185. As soon as you know that, we now know how to compute the width and the x position of each of these views, because B's x position would just be here. We could find out C's x position, which would be here, by 10 plus the width of this view, which we know to be 185, plus 10. So we know that C's x position would be 205. We know its width, so we can compute values for these. The other thing that we did here, if we wanted to, we could have set constraints between the latitude and longitude label in exactly the same way. So basically had, a constraint here, the box around this label here, the box around this label here, a constraint here, and a constraint here. And that would have worked, that's fine. But we can also do this in different ways. As long as the information is available to the solver, it can work it out. And what we suggested was to constrain the left side of these labels with the accompanying view. So basically added, didn't want that to happen, I apologize for that. I'm doing annotation on my iPad and this doesn't always go well. It sometimes skips out of it. Basically what we did there was we put a constraint on the left side of these here. So then all we're saying is the x position of each of these labels is equal to the x position of the text field. And you can see how that would provide the necessary information for their positioning. That covers the basics of what we've got here, and it's literally a matter of whether or not you can solve these kind of algebraically. So if you imagine back to the kind of mathematics problems you were probably given in high school, where you might have been given some of the values and asked to solve for the others, that's exactly what the solver is doing here. So your job is to be able to provide enough information for it to be able to get exact values for things. A couple of other things I want to talk about before I finish this video. I want to talk to you about labels, because labels you can specify a width, but obviously the text may not take up all of that width. So it might be that we constrain this label up here to be this size. And that's fine. It looks like the label is much shorter and only takes up this much space, right? But it's actually a bigger view. And what happens is if the text is longer than what fits in that view, it will actually truncate it. And what that means is it will cut it off, and at the end of the view over here, it'll put in an ellipsis to show that there's some content hidden. Now, every label has a lines property. By default, this is set to 1. And what that means is the text field has exactly one line. So when it computes its height, it does so based on the text size that's being displayed in it and the number of lines. If you want a label that is much higher, that takes up multiple lines, that's fine. It's just a matter of instead setting this equal to 2 or 3, right? And then it will be 3 times as high. Obviously, if the text you're putting in that label doesn't require 3 lines, it will display it as normal. If it requires more than 1 line, it will break it and put a line break in, and then it will show an ellipsis at the end if it still can't fit the content in. The final thing that you can do that's very useful with auto layout is you can set the lines property to 0. And if you set it to 0 and it has a known width because of other constraints, the height will be computed in order to fit in all of the text string that you give it. So this is something we did in the one of my early lecture demos, I think in about week 3 or 4, where I showed the TV app example where we showed episode overviews, and all of them were different length. They're all a paragraph of text. Some of them were 3 lines, some of them were 10 lines. And We just used a label for that with this lines property equal to 0, and in that case the height of the label is computed, and you can constrain the bottom of that view to other things and it will push them down because it knows its height needs that much room to show the text in it. So that's very useful to us, and that's something you can use even within things like table view cells. So we haven't talked about table view cells exactly, so I want to show one more thing related to table view cells. Let's say you've got a table view and we don't know its height exactly, but we know it's got like some text field or label and something else. Now, if you've got constraints between these things and the side of the view, like this, but nothing to the bottom, what happens is that it doesn't know how tall the table view cell needs to be. So what it does is it just uses a default height. That might be something like this, and you might find that you've got views that are cut off and not shown within your table view cells. So that's bad, and all you really need to do to fix it is you need to add a constraint between the bottom of the lowermost element and the bottom of the table view cell, and that causes it to compute the height of the table view cell and make enough space to display it. Obviously then if you want an element like this one to be a UI label and have it be multiple lines, then its height will be computed to be larger and it will push the size of the table view that's required. And that's exactly what I did for that TV app example. Okay, thanks for watching. Hopefully this has been an informative little look at auto layout constraints. If you have any further questions, please ask them in consultation or on the forums. Thanks.